physics students. Today we're going to be talking about the notes from our first unit in physics, which is our unit on describing motion. Later on we're going to pursue units. Unit 2 is explaining that motion, and then we're going to look at some units later in the year having to do with energy, waves, vibrations, and even electricity and magnetism. But classical physics starts with the need to understand just how to take a look at something that's moving and describe it. This is a branch of physics called mechanics, or the study of motion. So if you're going to study motion, the very first place that you should start is to understand that motion is going to take place in certain dimensions. There's one-dimensional motion, which is only going to move through one dimension of space during a certain amount of time. And then later on, we'll be taking a look at two- and even three-dimensional motion later in the chapter. So to start with, what we want to talk about is one-dimensional motion. This is the simplest form of motion because objects can move on several different axes. They can move left and right, up and down, and forward and back. In math class, if we were going to graph these, we would call these motions moving on the x-axis, which is left and right, the y-axis, up and down, and the z-axis, which would be forward and backward motion. Notice that all these axes are lines, and so because of that, this is a good example of one-dimensional motion if they're moving in any one of those directions, left, right, up, down, or forward and back at a specific time. Now, a good example of this motion might be, for instance, a train, a subway train. Assuming the track is straight, that would be a good example of maybe forward and backward, or maybe left and right motion. But essentially, it's a number line. Maybe an elevator would be an example of a vertical motion, moving on the y-axis, up and down only. But it's definitely one-dimensional motion. In addition to the three dimensions of space, we also recognize there's one dimension of time. So the world we live in is a four-dimensional motion, a four-dimensional world with four dimensions of motion. Three dimensions of space, left, right, up, down, forward and back, and one dimension of time. So motion takes place over a time interval. And it depends on something called a frame of reference. Now, the frames of reference are ones that I just mentioned. The actual axes themselves, the x, y, and z axes, are different frames of reference for us to be able to determine if something is moving. It's a system for helping us to identify the exact location of an object in space on one of those number lines, or maybe more than one of those number lines, and in time. The best frames of reference are going to be stationary objects, which we call a reference point. On a number line, a stationary object that we're comparing an object's motion to, we're probably going to label as 0 on the number line. So, if a car is driving by a tree, we're going to make the tree, the non-moving object, 0 on our number line. And if it moves to the right or to the left of the tree, it moves along the x-axis, either in the positive direction or the negative direction. That is, if it's to the right or left of our reference point. 0 on the number line, the stationary tree. When we start to look at these directions that an object is moving and their location relative to some reference point on an artificial number line, we're looking at a physics concept called displacement. You certainly can look up the definition of displacement in your book, but kind of an everyday explanation or definition of displacement is that it's going to be a measure of the relative Or sometimes instead of saying an object in physics, we'll say of a particle. So, a few important things about this definition. It's a measure. That means it can be measured either qualitatively or quantitatively. If we're using a number line, well, that's clearly quantitative. It's relative. That means you're relating the location of that object on a number line to something else, some point of reference. Again, the best point of reference would be 0 on our number line, and it's going to be a stationary object, ideally. So, if something is displaced, that means it's moved relative to the position of something else that is not moved. Now, in physics, we use variables to help us identify relationships. So for an object, we want to assign some variables to help us understand displacement so that we can graph its motion and so that we can make an equation to describe its motion. Well, we already have axes, the x-axis, the y-axis, and the z-axis, and these axes already afford us some letters that we can use for some variables. So often we say the equation for displacement is delta x equals x final minus x initial. Anytime you see the variable delta in physics and a lot of other sciences, this is a Greek letter that means change in. And what we see here with the letter x, this means horizontal position. In other words, on the x-axis, if we had a number line that described things moving left and right, its position on the number line would be denoted with the variable x. So what we really have here is an equation that says the change in position from one point on the number line to another point on the number line can be identified by taking our final point and subtracting the initial point. So imagine that we had something that started at the number 2 on a number line, and then it moved to the number 5 on the number line. Our total change in position is going to be 3 steps on that number line, because it ended at 5 and it started at 2. For a total change of 3 units. Could be meters, feet, miles, we don't know. Now, remember, in physics, pluses and minuses, the sign in front of a number, show direction. Again, if a number in physics is positive or negative, positives and negatives indicate direction. Positives, if they're on the y-axis, is going to mean up. On the x-axis, it's going to be to the right. But we could also use directional indicators, north or east, as well. On the z-axis, positive is going to mean forward. Negative numbers on the y-axis are going to mean down. On the x-axis are going to mean left. And on the z-axis are going to mean backward. Again, we could also use directional indicators here, such as south, west, or we could even use angles, as you'll see later on. A good example of all these different directions is in Table 1 on page 42 of your book. And so please note that I wrote the equation for displacement here in terms of x because I'm thinking of an object that's moving left and right. I could just have easily used y or z if I was thinking of an object moving up and down or forward and back. So here we can see Table 1 in your book has positive and negative displacements. You can take a look at these and see, for instance, a positive displacement is one where the object ends up to the right of whatever its initial position was or the reference point. Negative displacements are ones where the object ultimately moves and ends up to the left of its starting point or the point of reference. The starting point in physics is called the origin. Notice that the origin is not always the point of reference, but often the starting point makes a good point of reference if it's stationary. Let's go ahead and try to calculate the displacement of this gecko. Here we can see that we're being asked to use the guess method. The guess method means that we're going to list our givens, identify our unknown, list an equation that we could use to find the answer, solve the problem, and then the final S stands for your solution. And when we mean solution, what we mean is make sure you have the right number of sig figs, that you put it in scientific notation, that you box your answer, and that we can easily see what your answer is with the correct units and the correct positive or negative sign to indicate direction. So as we move along here, the first thing we're going to do is list our givens. Here we can see that the initial position on this left and right number line for the gecko is a little past 20. I'm trying to guess what it is. I'm going to say it's 24. 24 what? 24 is a magnitude, a number. We're looking for a unit, so maybe 24 centimeters. We can see that its final position looks to be about maybe 84 centimeters. And notice that it's 84 centimeters to the right. So that means when we do our calculation, we would expect to produce a positive number. What is the unknown? Delta x, our displacement. What equation could we use? Well, the only equation we know so far is that our displacement is going to be our final position minus our initial position. Let's go ahead and calculate our answer. Our final position of 84 centimeters minus our initial position of 24 centimeters equals a total change of 60 centimeters. And notice this is a positive number, indicating that our gecko ended up 60 centimeters